Hey, all right, so how do we graph quadratics in standard vertex form? Oftentimes people just call this vertex form, and that's a times x minus h squared plus k. Well, we should recognize this because we saw this with parent functions. H is just our shift right and left, k is up and down, and a is the stretch and compress. But why do they call it vertex form? Well, because for quadratics, the vertex is located at HK. To help you see that a little bit, here I brought in an example, y equals negative x plus 3 squared plus 4. So this is shifted left 3 and up 4, right? The original vertex was at 0, 0. It went left 3 and up 4. So now it's at h and k, negative 3, 4. Now remember that h is always the opposite of whatever's inside the parentheses. And it has an axis of symmetry that goes right through that h as well. So in this form, we can say that the axis of symmetry is at x equals h. And you can also see in this last example that this a out here was just a negative, and we could say it's a negative 1, so that just flipped the graph over. All right, so let's do some examples. For these first examples, we're only going to find the vertex and the axis of symmetry. All right, so I know that the vertex is at HK. So notice that whatever's inside the parentheses, we're going to use the opposite. So the vertex is going to be at positive 3, positive 1, because the k out here was a positive 1. And so the axis of symmetry goes right through the x of the vertex. So it's x equals 3. In this next example, what is h? Well, see, we don't have anything inside of a parentheses, so h is actually 0. So we're going to say 0. And then k is that negative 1 that's hanging out to the outside. Okay? So we have an axis of symmetry that is x equals 0. All right, pause the video and try the last one for yourself. Okay, so what you should have got on C is that the vertex is at negative 2, 0, because there's no k hanging outside. And so the axis of symmetry is at x equals negative 2. Now, just before we graph this example, I want to remind you that this shouldn't be anything new for you, okay, just based on your knowledge of parent function rules. So let's look here. For the graph of 2 times x minus 3 squared minus 1, the very first thing I need to find is the vertex. So we should be pretty good at that now. This vertex is at 3, negative 1. So I go to 3, negative 1, and I plot my vertex. The axis of symmetry is going to go right through the x of the vertex, so it's going to be x equals 3. And remember, I keep putting x equals because the axis of symmetry is a whole line. So I go right through there. And then finally, I just use the fact that a equals 2. So that's the stretch of this function. Since it's positive, I know it opens up. And each y will be stretched by a factor of 2. So instead of going over 1 up 1, I'll go over 1 up 2 on each side. And then I could go over 2. Normally it would be over 2 up 4, since 2 squared is 4. But this would be over 2 up 8, and that actually goes off of our graph. So that's the graph. Be sure that you have the axis of symmetry labeled either over here, or you could write it right here on the graph. You could put x equals 3. All right, so pause the video and you give it a shot. Okay, so you should have seen that the vertex is at negative 2, 1. Right here, this is my vertex. This graph has a maximum. The maximum value is the y value 1. The axis of symmetry is x equals negative 2. Since a is negative 1/2, we know it opens down and it's compressed. So instead of going over 1 down 1, I had to go over 1 down a half. Or instead of going over 2 down 4, I went over 2 down 2. Because each of the y stretches get compressed by half. All right, the last thing that I want to do is try to change from standard vertex form to general form. And again, a lot of people just say general form, they just call that standard form, and instead of standard vertex, they just call this vertex. So you might see this say, go from vertex form to standard form. Anyways, the way that we do this is we have to think, okay, what does this 2 out here mean? It means that it's squaring the x plus 2. That means that we actually have y equals negative 5 times x plus 2 times x plus 2 again plus 8. At this point, we're going to want to distribute or FOIL. And what I mean by that is this is how we multiply the x plus 2 times the x plus 2. So we have y equals negative 5. Leave that out for a little while. And then we'll do x times x is x squared. X times 2 is 2x, and so on. 2 times x is 2x. 2 times 2 is 4, plus 8. So notice I kept it in parentheses still because I haven't multiplied the negative 5 by all this stuff yet. So I'm going to have to distribute one more time this negative 5 to everything. So I have y equals negative 5x squared minus 10x minus 10x minus 20 plus 8. Now all I have to do is combine like terms and I'm done. So y equals, there's no other squared terms, so it's negative 5x squared. Of the x's, I have negative 20 x's, and then negative 20 plus 8 is negative 12. So this and this will produce the exact same graph. It's just this one is a lot easier to see the vertex of negative 2, 8. For this to find the vertex, you would have had to use opposite of b over 2a and all that stuff. But you should be able to graph from standard or general form or just vertex form. All right, and that's all.